Hey guys, welcome back. This is going to be attempt number 2 to help you guys this week. We are on page 466. I'm going to be doing the odds on numbers 1 through 20. Um, so, this lesson is about multiplying and dividing expressions that have square roots in them, radicals. It has a lot to do with FOILing, so hopefully you guys remember that from a couple chapters ago. It just has square roots in it this time, so we're going to have to use some of the stuff from previous lessons. I don't think this lesson is as hard as last week, but you guys can be the judge of that. I'm going to jump in here with number 1. It says 2 minus square root of 3 times 2 plus square root of 3. Okay, you probably don't recall this, but back when we did the FOILing chapter, when you have two expressions that are the same except for one's a minus and one's a plus, when you FOIL them, the outside and inside should cancel out. I'll go ahead and do the entire FOIL, and also we called these conjugates, which we're going to need to know that for this lesson. There you go, conjugate. Conjugates look almost identical. One has a minus in the middle, the other has a plus in the middle. Okay? And they're special because when they FOIL, stuff cancels out. So FOIL, remember, stands for first, outside, inside, last. First, the first terms in the parentheses are 2 and 2. What is 2 times 2? 4. Okay? Outside, going out, is 2 times square root of 3. 2 times the square root of 3 doesn't really simplify well. It's just 2 square root of 3, which means 2 times square root of 3. Since it's positive, I'm going to put a plus right there. Inside is 2 times, I'll consider that negative square root of 3. 2 times negative square root of 3 is negative 2 square root of 3. So since it's negative, I'm going to put a minus right there. Okay, and then last would be the last two, the last in the parentheses, are negative square root of 3 times positive square root of 3. Negative times positive is negative. Square root of 3 times square root of 3 is square root of 9, which is just normal 3. Remember, when you square a square root, it just becomes a normal number. Square root of 3 times square root of 3 ultimately is just 3. Negative times a positive is negative, so it's negative 3. Okay, you can simplify these two in the middle like normal. That's normal for FOILing. 2 square root of 3 minus 2 square root of 3 is 0 square root of 3. No more square root of 3's. So those are just going to cancel out right there. So we got 4 and minus 3 are left. Okay, well, those can go together too. That's a little bit new for us. So 4 minus 3 is 1. So the answer to number 1 is 1. All right, any questions? No? Good. Okay, gonna jump to number 3. Looks like another conjugate. It's square root of 3 minus square root of 11. Okay, you can multiply square roots just like you multiply normal numbers. They can go together. You just can't multiply a normal number with the square root. They don't simplify well. So FOIL first, square root of 3 times square root of 3. Normal 3 again. So I'm just going to put a 3 there. Outside and inside. Since I'm going to cheat a little bit on this one. Since I know these are conjugates, I know my outside, square root of 11 times square root of 3, square root of 33, and my inside, negative square root of 33. Those are going to cancel out every time on conjugates. Not all of these problems are conjugates, so we're going to actually have to do that later, but these are. So really all I need is my first, which is 3. And then my last square root of 11 times square root of 11, square root of 121, which is 11. Okay, but actually this was a negative square root of 11 times a positive square root of 11. So that is negative times positive, negative 11. So I'm going to put minus 11. What's 3 minus 11? Negative 8. So that is number 3. So notice when we're multiplying conjugates with these square root things that there is no square root at the end. And that's the trick we need for later. It's just a normal negative 8. Normal answer. All right, jump into number 5. Number 5 is not conjugates. It's 5 minus square root of 5 minus square root of 3 squared. Which means we're going to take all of this times itself. This times itself. That's what squared means. Squared means take that number times that value times itself. So this times another one of these. All right. So on this FOIL, the outside inside will not cancel each other out. They will look the same, but they will not cancel out. So first, square root of 5 times square root of 5. Square root of 25, normal 5. Okay, outside, going out, square root of 5 times negative square root of 3. Negative square root of 15. Okay. Square root times square root, still square root. Inside looks almost the same. Negative square root of 3 times square root of 5. 3 times 5, 15. So it's negative square root of 15. These do not cancel out. I'm not done yet, but these do not cancel out. A negative and a negative are going to be more negative. Okay, it's not positive square root of 15 minus square root of 15. That would be 0. It's negative square root of 15 minus square root of 15. So it's going to be go down. All right, and then the last negative square root of 3 times negative square root of 3. Negative times negative is positive. Square root of 3 times square root of 3 is 3. All right. Now, let's start with the normal numbers. I see a 5 up here and a plus 3 back here. 5 plus 3 is 8. Those can go together. Okay, if there is no number in front of the square root of 15, hopefully you guys figured this out from last week. That means it's like there's one of them. Kind of like if there's no number in front of an x, that means there's one x. Okay, so if I had negative 1x minus 1x, that would be negative 2x. Same thing on square roots. If I have negative 1 square root of 15 minus 1 square root of 15, that's minus 2 square root of 15. All right, does that simplify any? No, it doesn't. It doesn't get any neater than that. Okay, if you plug it all in your calculator, it'll give you weird decimal, but we're not doing weird decimals. We're just going to leave it right there. You cannot add and subtract, just like you can't add and subtract 8x and 3y, you cannot add and subtract square roots with normal numbers. So that is the answer to number 5. All right, number 7 says square root, or just 7 plus square root of 3, 4 minus square root of 11. All right, so start with FOIL first. 7 times 4. Outside, 7 times negative square root of 11 will be negative 7 square root of 11. Doesn't simplify, just kind of copy it down. Inside, square root of 3 times 4. So 4 square root of 3. Both of them are positive, so it stays positive. And last is square root of 3 times negative square root of 11. 3 times 11 is 33, so it's negative square root of 33. Okay, sometimes square roots can simplify, so I should think about it. 33 3 is too simple already. It's just a prime. It's not going to break down any. 11's a prime. It's not going to break down any. 33 is 3 times 11. Remember, to simplify a square root, you have to be able to have a double in it. And if 3 and 11 are the only thing that goes into 33, it's not going to simplify. Okay, what else can I do on this problem? Well, nothing. This is just a normal number. This is like square root of 11, square root of 3, square root of 33. Those are all different kinds, so they're not going to add together. Basically, it's the idea of you can only add like terms. You can only add x's with x's, y's with y's, square root of 11's with square root of 11's. So this is actually all we can do. It doesn't get any simpler than that without changing it to a decimal. So when it says simplify, it doesn't mean a decimal. It just means do that and then stop. Okay, that's number 7. Number 9, square root of 6 minus square root of 2, square root of 8 plus 4. All right, I noticed something that's going to give us a little bit of trouble. Square root of 8 can simplify because it's 4 times 2, and 4 is 2 times 2. There's some 2's in 8. There's some doubles in there. We could simplify it now, but might as well. I think I'm just going to wait till the end to worry about it. I'm not sure which way is easier, but I'm not going to worry about it right now. Yeah, probably easier at the end. So FOIL, we're going to start with first. Square root of 6 times square root of 8. Square root of 48. That's definitely going to simplify. Outside, 4 times square root of 6. Doesn't really mix well. Inside, negative square root of 2 times positive square root of 8 is negative square root of 16. Okay, and then last, negative square root of 2 times 4 is negative 4 square root of 2. All right, lots of stuff going on here. Okay, square root of 6, that doesn't simplify. 6 is 3 times 2, no doubles. Square root of 2 doesn't simplify. Square root of 16. What times itself equals 16? 4, yeah. So, I'll rewrite this with a 4 right there. Save 48 for last because it does simplify, so we need to do some work on it. What goes into 48? Well, 6 times 8. I know that. That's where it came from up here. 6 is 3 times 2. 8 is 4 times 2. 2 times 2. Okay, so we can put all of the doubles in the front, and then the leftovers are going to go in the back. So I see 2 double 2's. So 2 times 2 times 2 times 2 is going to go in the front, which 2 times 2 times 2 times 2 is 16. And I have a leftover 3 that's going to go in the back. Okay, square root of 48 is the same thing as 16. Square root of 16 times square root of 3. Square root of 16, we just kind of mentioned that up there, 4. So this is 4 square root of 3. Okay, so I'll just bring the rest of the stuff down so it's all on the same line. All right, is there anything else we can do with that? No, they're all not like terms. This is square root of 3, square root of 6, just a constant normal number, and square root of 2's, so they're all different. So we're going to stop there. All right, number 11 is a different section. It's going to be pretty short and sweet. Conjugates, we already mentioned them at the top. Conjugates are basically just the same thing except for one's got a plus, one's got a minus in the middle. And that's it. So on number 11, it says negative 3 plus square root of 5. Okay, the conjugate would just be, switch that sign in the middle. It'd be negative 3 minus square root of 5. Notice I didn't switch both signs. I didn't switch the negative out in front. Okay, just the thing in the middle. So that's all they're asking for at number 11. Just write the conjugate, the end. The reason they're doing that is because we're going to need to use that for some problems on 13 through 18. Okay, number 13 says simplify 1 over 2 plus square root of 3. All right. So what can we do with that? There's not a lot going on there. Well, okay, the standard convention is you cannot, to have it in the simplest form, you cannot have the square root of 3 or any square root, any radical in the denominator. Okay, how do we get rid of it? Well, last week we did some of these problems and you would just like multiply the top and bottom by square root of 3 and that kind of fixed our problem for us. It's not going to work this time. If I multiply the bottom by square root of 3, it would look kind of like that. And I'd have to distribute it out. I'd get 2 square root of 3 plus 3. So we'd still have a square root. It doesn't solve our problem for us. So what we're going to have to do is use the conjugate. Because remember from 1 and 3, the conjugates get rid of square roots. So instead of multiplying by square root of 3, I'm going to multiply by the conjugate of 2 plus square root of 3. What's the conjugate of 2 plus square root of 3? 2 minus the square root of 3. Okay, but in fractions, if you do something to the bottom, you got to do the same thing to the top. Well, if you multiply the bottom by something, you got to multiply the top by the same thing. 2 minus square root of 3. Okay, because basically this over this, that's anything divided by itself is 1. If you multiply something by 1, it's the same value. It's just going to look different. All right, so let's start with the top, I guess. It's pretty easy. What's 1 times 2 minus square root of 3? Well, it's kind of the distributive property, but when you multiply by 1, it doesn't do anything. So the top is going to stay the same. Well, it's just going to be 2 minus square root of 3. Okay, the bottom is a FOIL problem. But because they are conjugates, we don't have to do the whole FOIL. We know the outside and inside are going to cancel each other out. So really we just need to do the first and the last. So the first is 2 times 2, which is 4. And the last is square root of 3 times negative square root of 3, which is negative square root of 9 or just negative 3. I'm going to put a minus 3 right there. All right, is there anything else we can do? Yes, the bottom is 4 minus 3. So that's 1. So, well, let's fit over here. So 2 minus square root of 3 over 1. Well, what's anything over 1? It's just itself. So really, the simplest, easiest way to write this is just 2 minus square root of 3. Okay. So now we still have a square root. There's no square roots in the denominator. Actually, there's kind of nothing in the denominator right now. That is the answer. Okay, number 15. Same thing. It's got another couple square roots on the bottom this time. It says square root of 11 over square root of 3 plus square root of 2. Okay, so what's my first step? Well, okay, again, I can't have square roots or radicals of any kind in the denominator. How do I get rid of it? I multiply by the conjugate. What's the conjugate of square root of 3 plus square root of 2? Same thing, except for switch the sign. Square root of 3 minus square root of 2. If you multiply that on the bottom, you got to multiply the same thing on the top. All right, Let's do the top again, I guess. So we're doing square root of 11 times all of this. So really this is the distributive property. What's square root of 11 times square root of 3? Square root of 33. What's square root of 11 times minus square root of 2? Minus square root of 22. Are those going to simplify? No, they won't. Square root of 33 is 3 times 11. That's not going to do anything. That's 2 times 11. And also they don't go together. They're two different types of square roots, so they're not going to mix. Okay, bottom. Remember, we're foiling here because it's 2 terms times 2 terms, but we're only going to do the first and last because they're conjugates. Square root of 3 times square root of 3 for the first is normal 3. The last, square root of 2 times negative square root of 2 is negative 2. Okay, so the bottom, can that simplify? Yes, 3 minus 2 is 1. And anything over 1 is just itself. So the answer is just square root of 33 minus square root of 22. The end. All right. Number 17. All right. On 17, they're trying to remind you of something that we did last week. What's different from 17 and the previous problems we did? There's only one term on the denominator. Okay, so we still can't have a square root in the denominator or a radical in the denominator. How do I get rid of the square root on the 2 there? Well, we're not going to use there's no conjugate for square root of 2, it's just one term. We're going to use the trick from last week. We need to multiply the bottom by square root of 2, but if we do that on the bottom, we got to do that on the top. Okay, why do we do that? What's square root of 2 times square root of 2? Square root of 4, which is normal 2. Okay, so there is, what that did basically is just got rid of the square root in the denominator. The top is 1 times square root of 2. You could say that's 1 square root of 2, or you could just say that's square root of 2. Does this simplify? No. Square roots, just like square roots of normal numbers, you can't really multiply them together. You can't divide them either. It's just gonna stay like that. All right, so 17, they were trying to remind you of last week's and differentiate between the two kinds of problems. Okay, 19 is kind of like the first section, but it's just more work. Does order of multiplication matter? Is 3 times 5 the same as 5 times 3? Is 5 times 3 times 2 the same thing as 2 times 3 times 5? Yeah, those are all the same. So order doesn't matter. So on 19, there's 2 of those that would be easier to multiply together first because they're conjugates. So I'm looking at the first and the third parentheses, first and third. Those are conjugates. They're going to be easy to multiply together, and I'll make our problem easier if we do those first. So I'm going to multiply square root of 5 minus 3 times square root of 5 plus 3. Okay, because they're conjugates, we don't have to do the entire FOIL. We just can do the first and the last. Okay, the first, square root of 5 times square root of 5. And last, negative 3 times positive 3. Okay, and what's 5 minus 9? Negative 4. Are we done? No, we're not. There's another thing to multiply by. So we multiply the first and the third polynomials. We still need to multiply that times the middle one, which was square root of 2 plus 1. So it's no longer a FOIL problem now because it's just the first thing we did turned into just a negative 4. Now it's more like a simple distributive problem. So what's negative 4 times square root of 2? And what's negative 4 times 1? Okay, do those mix? No, they do not add or subtract together. So That's all we can do, and that would be the answer. All right, hopefully this made sense to you guys. Good luck with your assignment.